This experienced factory worker is assembling General Motors' latest fifth-generation small-block V8 engine. Much of the final assembly of these V8 engines is performed by hand, with skilled technicians using pneumatic torque wrenches. So, welcome inside the Tonawanda Propulsion Systems plant. This is where engines are assembled for vehicles such as the Chevrolet Silverado, Corvette, Sierra, Suburban, and Cadillac Escalade. Since beginning operations, this factory has produced an incredible 75 million engines for General Motors vehicles. Inside the factory, employees make around $40 per hour on average. Because of the huge number of engines produced, occasional recalls or service bulletins do occur, but engine-specific recalls are relatively rare. The GM small block is the longest continuously produced V8 engine family in history. Since its introduction in 1955, more than 100 million small block V8s have been built. The very first small block, a 265 cubic inch V8, debuted in the Chevrolet Bel Air. Compact, powerful, and affordable, it quickly earned the reputation as the engine that changed everything in American performance cars. The simple pushrod design made the engine durable, low profile, and capable of producing strong torque. Its compact size and light weight made it easy to fit in nearly any vehicle, from cars and trucks to race cars. Throughout the factory, all engines are moved either on these conveyor belts or by automated guided vehicles. Transfers between workstations are closely monitored, and every step must be precisely coordinated. Right now, you're watching the finished engines being moved to the main assembly line, where they will be installed onto the vehicle's chassis. The process you're watching now is called the marriage. This is the moment when the heart of the car, its engine and transmission, is joined with the body, creating a fully functioning, road-ready vehicle. This step is critical as it forms the backbone of the car and ensures everything is properly aligned for performance, safety, and durability. Once completed, the vehicle continues down the assembly line for the installation of interior, exterior panels, electronics, and final quality checks. But now you're watching powertrain production in Romulus, Michigan, where the renowned HFV6 engine is built. It produces the 10-speed automatic transmissions used in vehicles like the Chevrolet Silverado, GMC Sierra, Cadillac Escalade, Chevrolet Tahoe, and GMC Yukon. Producing both the modern V6 family and advanced 10-speed transmissions under one roof allows GM to integrate powertrain manufacturing more tightly and respond to demand shifts in both engines and transmissions. The 10-speed transmission is a key component for full-size trucks and SUVs, helping with performance, efficiency, and competitiveness in a demanding market. The HFV6 engine lineup gives GM flexible powertrain options for mid-size vehicles and luxury brands. Certain early versions were subject to timing chain wear and cam phaser issues in specific conditions, such as extended oil change intervals or heavy-duty use. This is the assembly of the Chevrolet Corvette 6.2-liter V8 LS9 engine. When it debuted in the 2009 Corvette ZR1, this engine produced 638 horsepower, making it the most powerful production engine GM had ever built. With only around 4,700 Corvette ZR1s produced between 2009 and 2013, the LS9 remains a rare collector's item. Each LS9 engine was hand-built at GM's Performance Build Center in Wixom, later relocated to Bowling Green, Kentucky. A single technician assembled each engine, and some units feature a plaque with the builder's signature, a unique mark of craftsmanship. Unlike most LS engines, the LS9 uses a dry sump system, typically reserved for race cars, ensuring consistent oil flow even during high-speed cornering. The assembly begins with a lightweight aluminum engine block, carefully cleaned, inspected, and precision machined. Cast-in iron cylinder liners are incorporated for strength and durability, while 6-bolt main bearing caps help the block withstand high boost pressures. The block is made from 319 aluminum, designed for both lightweight performance and toughness. The rocker arms, push rods, and lifters are installed with precise preload settings. Every component is torqued to specification and carefully checked for proper clearance. A hydraulic roller camshaft is installed and tuned for both performance and smooth street drivability. The timing chain, tensioner, and gears are carefully fitted to ensure precise engine timing. Next, the factory technician attaches a nameplate, Wixom Performance Build Center, assembled with pride by Mike Priest. Titanium rods are ultralight and extremely strong, usually found only in exotic sports cars. Their use in the LS9 is part of what allows it to rev high, while handling massive supercharged torque. The Tonawanda engine plant in Buffalo produces over 1,500 V8 engines every day. Highly automated processes, such as head assembly, are extremely efficient, often completed in under a minute. You are now watching the engine being mounted to the transmission and lowered into the vehicle's chassis. To position the engine over the chassis and lower it into place, workers use a crane integrated into the roof of the factory hall. As you can see, these engines are truly massive, one reason why vehicles powered by them command higher prices. This is General Motors' Romulus Engine Plant, a facility with deep roots in General Motors' powertrain operations. In the 1980s, it transitioned to engine production, and since then has built over 10.8 million V8 engines and more than 6.6 million V6 engines. As of around 2020, the Romulus engine plant employed roughly 1,400 hourly workers and spans approximately 1.4 million square feet. This is Saginaw Metal Casting Operations, a long-standing GM foundry with a history dating back to 1919. This facility produces engine blocks and cylinder heads using both precision sand and semi-permanent mold casting techniques. It plays a critical role in supporting GM's engine plants, supplying aluminum heads for engines such as the 3.6-liter. The casting process typically begins with molding, which can involve green sand, dry sand, semi-permanent molds, or permanent steel molds. Once the mold is prepared, molten aluminum is poured into the mold spout. The metal flows downward through runners and gates toward the head deck surface, filling the mold cavity to create the desired shape. For precision applications, such as lost foam casting, a foam pattern is used that vaporizes when exposed to the molten aluminum. The aluminum takes the place of the pattern, producing highly accurate, detailed castings that meet the demanding standards required for modern engines. This combination of advanced casting methods and skilled craftsmanship ensures that each engine component meets GM's strict quality and durability requirements. Now, for comparison, we move to the Bentley factories in the UK, where, in addition to V8 engines, the massive W12 engines are also assembled. This gives you a chance to compare working conditions in automotive factories in the United States and the United Kingdom. This is how the massive W12 engines were manufactured at Bentley's Crewe factory in England.
And lifting.
Built by hand at Bentley's historic Crewe factory in England from 2002 to 2024, the W12 wasn't simply assembled, it was crafted. Each engine is made from hundreds of precision components and takes approximately 8 hours of precise hand assembly. Every unit undergoes over an hour of rigorous testing. Leak tests, cold tests, fire-up tests, nothing is left to chance. In the footage you're watching, technicians are manually installing the crankshaft, followed by the pistons. A ceiling-mounted crane swings into position to help lift and maneuver the massive components. This is not just manufacturing, it's artistry. The W12 powered Bentley's most iconic creations: the Batour, Continental GT, Bentayga, Flying Spur, and Mulliner models. When it launched in 2003, it produced 552 horsepower, later evolving to 650 horsepower in Mulliner editions, and finally reaching a staggering 740 horsepower and up to 1,000 Newton-meters of torque in the Batour. It became known for its silky, smooth torque delivery, its distinctive and charismatic engine note, and its record-setting performance. In 2025, Bentley transitions entirely to hybrid powertrains, retiring the W12 from all models. A chapter closes, but the legacy of this extraordinary engine will stand forever. This unique W layout combines two compact V6 engines onto a single crankshaft. The result is the smooth power of a 12-cylinder in a package that's shorter, lighter, and more responsive than a traditional V12. In 2015, the W12 received a major redesign. Bentley introduced the W12 TSI, featuring twin-scroll turbochargers, cylinder deactivation, and both direct and port fuel injection, more power, better efficiency, and cutting-edge tech. Over 105,000 of these engines were hand-built at Bentley's Crewe factory over 22 years. The crankshaft alone is a masterpiece of engineering, incredibly strong and designed to handle massive torque. The updated W12 TSI became the most advanced 12-cylinder engine on the planet. With innovations like dual fuel injection, twin-scroll turbos, and split cooling circuits that keep temperatures perfectly balanced. Some parts inside this engine are machined to tolerances tighter than 4/10,000ths of an inch, more precise than many Formula One engine components. After assembly, every single W12 went through a controlled test cycle. Leak testing, cold cranking, full heat runs, and vibration checks. Each engine spent over an hour on a high-tech test bench to prove it was worthy of the Bentley badge. Enjoy this video without unnecessary music or commentary. Just pure engineering and raw performance. If you love real machinery and live for horsepower, this is your kind of content. The pistons and crankshaft in the Bentley W12 are balanced with such extreme precision that the engine produces virtually no vibration, not at idle, not at high RPM, not even under full load. The entire rotating assembly spins with a smoothness that feels almost unnatural for a 12-cylinder powerhouse of this size. Every engine passes through a small team of elite builders. When the final torque wrench clicks for the last time, that team is allowed to sign or tag the engine. Their initials become part of the engine's permanent record. It's a quiet but powerful reminder that these machines carry the identity, pride, and craftsmanship of the people who assembled them. Although the W12 concept originated within the Volkswagen Group, every single Bentley W12 ever made, from the first prototype in 2002 to the last unit in 2024, was built exclusively at the Crewe factory in England. Even when the engine appeared in high-end Volkswagen and Audi models such as the Phaeton and Audi A8, the heart of those cars still came from the same place, the Crewe engine room. As the production era came to an end, the final W12 engines were built in an extremely limited run of just 18 units. Each one received special calibration, hand-measured balancing, and individualized tuning to ensure perfect performance. These weren't mass-produced. They were the final, ultimate expression of a two-decade engineering legacy. Bentley officially ended W12 production in 2024 as part of its Beyond 100 strategy, a commitment to move the entire brand toward hybrid and electric powertrains. Right now, you're watching the moment when the engine meets the machine, mounting the W12 onto the chassis frame, followed by the installation of the front and rear axles. This is the transition from a powerful heart to a living, breathing vehicle. The W12 chapter is closed, but its legacy lives on in every mile, every exhaust note, and every engine that proudly carries the initials of the people who built it. The very last W12 engine ever built has been preserved permanently in Bentley's Heritage Collection, a time capsule of engineering excellence, frozen in history, so future generations can see what true mechanical craftsmanship looked like. And if watching this sparks a mix of nostalgia and heartbreak, you're not alone. The good news is that you can still own a Bentley powered by this legendary engine. Pre-owned Continental GTs, Flying Spurs, and Bentegas with the W12 are out there, still roaring, still carrying the legacy forward. Bentley's Crewe facility on Pims Lane is where all of this happens. It's a sprawling campus employing roughly 4,000 people, many of whom are second or third generation craftsmen with decades of experience. Inside the main assembly hall, a single 8-hour shift handles vehicle body construction and the final build. Around 700 workers move in harmony, an orchestra of specialists turning components into rolling works of art. What you're seeing now is the power and torque verification on the spin test bench. Before any W12 is allowed to move further down the line, it has to prove itself. But now, you're watching the production of Bentley's smaller V8 engine, also handcrafted at the UK factory in Crewe. This engine has a remarkable history at Bentley, first debuting in the 1950s and continuously refined over more than 6 decades to meet modern standards while retaining its classic character. With just a light press of the throttle, the system can deactivate 4 of the 8 cylinders, transforming the engine into a more fuel-efficient 4-cylinder when cruising. At the same time, it is equipped with twin turbochargers that dramatically boost power while maintaining the signature smoothness Bentley drivers expect. This V8 is paired with an 8-speed automatic transmission, specially calibrated to deliver seamless, effortless shifts, enhancing both performance and comfort. Coupled with Bentley Dynamic Ride and adaptive air suspension, the system ensures precise balance, poise, and a rock-solid foundation for the car, no matter the conditions. While Bentley is renowned as a global leader in W12 production, it isn't the world's largest V8 manufacturer. Yet this particular engine stands out for its incredible longevity, 61 years of continuous service, making it one of the longest-running production V8 engines in automotive history. Each engine assembly takes over 15 hours, and every unit is personally signed by the technician who built it, leaving a tangible mark of human craftsmanship. The V8 is celebrated for its immense low-end torque, producing a driving experience that feels effortless yet commanding, the very essence of Bentley luxury. Later versions could deliver more than 1,100 Newton-meters of torque, ensuring powerful performance across all conditions. Even though the engine retains its original 1959 block dimensions, it has evolved over the years with modern fuel injection, turbocharging, and emissions controls, staying compliant with regulations while preserving the unmistakable character and soul of Bentley engineering. Bentley Mulsanne Speed was a twin turbocharged powerhouse producing 530 horsepower, making it one of the most powerful luxury sedan engines in the world at the time. The final Bentley V8 engine rolled off the production line in June 2020, the same moment Bentley ended production of the Mulsanne sedan. This marked the conclusion of more than 6 decades of continuous V8 production, an engine that had become a symbol of Bentley's heritage. While many manufacturers moved to mass-produced standardized engines, the Bentley V8 represented something distinctly different: traditional British craftsmanship. Each engine was built by hand in Crewe, England, by a small group of highly skilled technicians. Before leaving the factory, every single V8 underwent a full dynamometer test. The engine was essentially run outside of a car under load to verify that it met Bentley's strict performance and durability standards. Only after passing these tests did the builder attach a plaque engraved with engine number, hand-built in Crewe, England, along with the technician's signature. To commemorate the end of the V8 era, Bentley produced a limited final edition Mulsanne. It served as a tribute to the iconic engine and the craftsman who built it. Once the engine was complete, it was carefully lowered into the chassis using an overhead crane. The engine was so large and heavy that workers could only guide it into position by hand. You are now seeing a key moment in the assembly process known as the marriage. This is when the chassis, complete with engine and drivetrain, is joined to the body of the car. Factory technicians usually work in well-coordinated pairs. Each person knows their role and performs it with practiced precision, ensuring the vehicle continues smoothly down the production line. From here, the nearly completed Bentley will continue through final assembly, inspection, and testing before it's ready for delivery to a customer. Even today, engine performance testing remains an essential step. Every Bentley engine is verified on a dynamometer before it ever reaches a car.